Hi everyone, and welcome back to my channel and welcome back to a new video. So in this video today, what we're going to be doing is we're going to be covering vertical projectile motion, and I'm going to be discussing the three types of graphs and how a certain object would behave depending on how it is moving in motion. Now this is going to be a three-part series, so a three-part video. So this is part one. So we're going to take the instance when we are going to take our position down as positive. So whenever you're doing vertical projectile motion, you're going to deal with three types of graphs. There's the position time graph, velocity time graph, and the acceleration time graph. Now with this, you can actually take any direction as positive as your reference direction. It could be up or down as positive. The slope, which is the area underneath the graph here, this is the slope. This will tell you about the change in the other quantities in the graph. So as I've got over here is I have got an instance where I'm going to take position down as positive, and the scenario is I am going to take a ball, I'm going to throw it downwards, then it's going to reach a maximum height which is on the ground and at the floor. So what we're going to do now is we're going to find out how does the graph behave. Now looking at the position time graph, we have position on our y-axis, time on our x-axis. Now how you would read this is the ball was dropped at an initial velocity of 0, and the maximum height of the ball is actually the ground position when it touches the ground. So this is how the graph is going to behave. This is the graph position at 0, so it's going to go up. This is the graph position as it's falling down because we're taking down as positive. Now this is how the graph is going to behave. If you notice, it's a parabolic shape because the gradient is representing the instantaneous velocity at any time interval. Depending on how long it takes for the graph to get to the ground, the gradient of the graph is representing the instantaneous meaning at that particular moment. That is the instantaneous velocity at any time interval throughout the graph. Now, if we look at the velocity time graph, we have the same thing over here. The ball was thrown at an initial velocity of 0. The final velocity is when the ball is hitting the ground at this moment. So it's at an initial velocity of 0, then it's going to fall, then the final velocity is when it reaches the ground down here. Then from there, what we can see from this type of graph is that we have a linear graph going up. The gradient is representing the acceleration, which is 9.8 meters per second squared, because that is how that's how fast the ball is accelerating as it's falling down. So in that we can also see that the in the position time graph, the motion is quicker because the ball was thrown at a certain velocity, and the gradient is steeper because it was thrown at an initial velocity. If you look at the same thing at the velocity time graph, the same thing is also occurring over here. This time we see that since the ball is going down, we have taken position down as positive. This is why the values and the graph is going to be above the t-axis, because we took down as positive. If we took upwards as positive, like you will see in the next video, you'll find that all of these graphs and their values will be below the t-axis over here. Now if you look at the last graph, which is the acceleration time graph, this graph does not have a gradient. Reason being is because acceleration does not change, and it is a constant value, and it has no gradient at all, because the ball is going to continue to move and accelerate at 9.8 meters per second squared no matter how fast it's going, because that's just how acceleration operates, and that's how the gravitational force, which is pulling the object down, behaves. So I hope you guys have enjoyed this video. If you guys have any questions, you're more than welcome to leave them in the comments, and I must definitely get back to you. Please like, comment, subscribe, and share, and I'll see you guys in part 2. Bye everyone.